So bias is about fair, and bias actually means that something is unfair. So a dice normally is unbiased. A regular fair dice is unbiased. Each side has an equal chance of coming up. Same thing with a deck of cards. Unless you're playing against a magician or a card shark, each card has an equal likely chance of coming out. So the individual event could be unbiased. You can also talk about a game. If I was talking about a game where I was saying you win if you get a 6, but you lose for any other number, well, there's a bias there towards you losing. So an unfair game could be things like we can have an unbiased dice, a fair dice, and that means 1, 2, 3, 4, 5, 6 are equally likely. Okay, so the dice can be good. Oh, I lost Margarita. But an unfair or a biased game could be a game. And we say that 1 to 5 you lose, 6 you win. And that one is a bias towards losing. Okay, so that's just, if you come across the word bias, what does it mean? If something is biased, it means that there is an unfairness. There is a greater chance of one thing happening than something else. It could be about individual events, or it could be about a game overall. Okay, if my dice had a weight in it, so if I had a dice and the bottom side was heavily weighted, and say this had 3 came up, then we could say this weighted dice is biased towards 3. So it's about whether or not games are fair or not. So if you have a massive weight in the bottom of a dice that makes one side turn up more often, the dice is biased. Most dice are unbiased. Each answer has an equal chance of coming out, but you can also make a game bias based upon the way it plays. Okay, so we've got unbiased dice. We need to write some probabilities for them. So I'm going to start off with a simple one and say, what is the probability? And you can put answers in here into the chat box if you want. What's the probability of scoring a 3? Okay. Anyone got an idea? I agree too. Yeah, Sabia. Yeah, I agree with that. Okay. So the way they've said 1 out of 6. Exactly right. And the way it comes about is you say the probability. You might see somebody write a capital P, and then inside you put the event. So 3 is the event. So if you put the event of a 3 into the brackets, we're saying chances of getting a 3 is the number of 3s divided by the number of outcomes. So outcomes are the number of things that can happen, and this is the number of ways to get 3. So there's 1 3 from 6 sides. Let's draw another one. What's the probability of scoring not 3? And that can also be written with a 3 dash or 3 with a line over it. Yeah, Margarita? So the probability, yeah, thanks Nizam, thanks Sabia. So there are 5 ways of getting something not 3 and divide it by 6. So that's 5/6. Notice the combination of both of these is always 1 or 100%. These two things can't happen together, but they cover everything that can happen. So their total probability is 1. Let's do a quick one. Probability of a 2 or a 3 There are two ways of scoring it out of 6. And unless somebody tells you to simplify, where's my pen gone? There we go. So only if you're actually told in the question to simplify do you actually turn to 1/3. On its own, if they don't say simplify, this is actually a good answer. You only have to go to 1/3 if they say simplify your answers. Okay, that's the basics of everything in today's lesson. You've got a number of situations. We get things like, what's the probability of scoring a king on a deck of cards? Actually, I'll put it in there. King from a deck, and I'll say in deck. So this is where your knowledge from the first lesson comes along. How many kings are there in a deck of cards?
4.
Yeah, so there's 4 kings. There they are. 1, 2, 3, 4. How many cards in a standard deck of cards? Yeah, 52. If I was to simplify that, does anyone know what that simplifies to? I can divide each of them by 4, so we get 1 over 4 into 5 goes once, carry 1 over to make 12. 4s into 12 goes 3 times. It's 1/13. Yeah? If I ask an alternative question, probability of a king in diamonds, here's my diamonds, and there's the king of diamonds. So we have 1 king in 13 diamonds. What we've actually shown here is to say these two games or these two events are equally likely. They will occur as often. If you pull out cards from a deck, putting the card back, you should see the same result as pulling out cards from diamonds and only diamonds. So what we've shown is that the number of kings drawn when you pull out 20 cards should be the same. I say should because probability nearly always says about. Okay. So sorry, Sabia?
The audio was breaking up. Could you please repeat what you said?
Right, it's actually what I just wrote here. We've done 4 kings out of 52 cards is 4 over 52. And that actually is the comparison between how many times you'd expect this thing to happen to how many times you would, how many tries you make. So if I tried 520 pulling out cards, I'd expect to get 40 kings. Now, what can be a little bit awkward or odd is if I only considered diamonds and I pulled out 520 cards, I'd still expect the same 40 because these two probabilities are the same. They say what fraction of the time do you expect to see this event occur? So that's what the probability means, is probability is the proportion of time, fraction, over time the event will occur. What we've shown with this one is if we do 20 drawings from a full deck, we'd expect roughly the same number of kings as if we were to draw 20 cards, each time putting the card back from one suit. Okay, so for the event will appear.